Please don't forget to like, subscribe, and comment. Thank you so much.
Join us at Like Learning School and experience a transformative education journey. Visit our website at www.likelearningschool.com or contact us at +2348085095144 to learn more and get started today.
So this is what you're giving. And you completed a table of values by substituting the values of x. You got all these, and then with that you plotted the graph. Okay, that is for the graph of f of x equal to this. F of x is f means y. Okay, just a quick review. Equal to all of this. Okay, and the first question says you should use your graph to solve this, which you have done. F of x equal to 0.5. You said it is y equal to 0.5, right? And we drew a line of y equal to 0.5 on the graph. And we pick the points where it crossed the graph. Minus 2.1 thereabout, minus 0.7, and then 2.5. Okay, we've gotten that. Minus 2.1, minus 0.7, 2.5. Okay, and then it says find the inequalities for k such that f of x equal to k has only one answer. Now show me again what you did. Let me analyze that. Show me again what you did on the graph. Are you still there? Are you still there?
Yes, I am.
Show me again what you did on the graph for the second part of the question. Find the inequalities for k such that f of x equal to k has only one answer. Okay, where it has only one answer is where it cuts the graph only in one place. Okay, did they say k is an integer?
No,
Okay, find the inequalities for k such that f of x has only one answer. Okay.
but I think
Pardon?
the answer is minus 3.5.
Okay, because it is somewhere even before the 4, even before minus 4, right? So probably let me draw it with this yellow line. Somewhere around here. But it's close to 4, really. It's close to 4. We can actually say 4. Let's use that, let's use that minus 4 you chose already. Let's use that minus 4. Because anything above 4, we have 2 values. It will cut here and here and here, or even 3 values. It will cut here and here and here. Now, if they said only 2 values, you would have used this something like this and this place, because it will cut here and cut here, or even 4, cut here and cut here. So it's less than minus 4, you're right. This graph y equal to less than minus 4 is correct. Is that the only one? Which other one?
Yes, k is greater than 2.
K is greater than 2. Okay, we can use that.
But
Yeah.
1.5.
And it's not exactly up to 2. It's not exactly up to 2. Okay, it's all right. It's all right. So maybe this is a graph of y greater than maybe 1.8. All right, that's fine. We can take that. So the values you chose Okay, less than minus 4, greater than 2, it's okay. It's fine, we can use that for the purpose of this work. If it is a graph you plotted on a paper, you can easily find those values. The important thing is that it must not cut to more than one place. You can only cut in one place. It shouldn't cut in two places. You shouldn't cut the graph in two places. You should cut it only in one place, like this, the one in blue and the one in yellow. Cut only in one place, so that's fine, because that's the only time k we have only one value. Okay, so di, what did you do? You didn't do it.
No, I did. On the grid, on the same grid, draw a graph for y equals 3x minus 2 for those values. So yes, I did it there. You can see the straight line I drew red.
Okay, just drew a straight line. I know you probably use just two values. Two. It's even one value because you already have an intercept. What's the intercept?
Minus 2.
So if you like, you can use two values, but one additional value. Of course, you must use at least two values, but one additional value is already there, which is the intercept, y equal to minus 2. You know, in other words, when x is 0, y is equal to minus 2, because that's the intercept. You know, so that can be plotted. That can be plotted. Minus 2 is here. Okay, it passed through it. And then any other one, when x, you just substitute any other value. I think that's cool. You got it properly. Maybe when x is 1, you know, what is y? When x is 1, we're going to have 3 times 1 minus 2. That's 1, am I right? Y will be 1. When x is 1, y will be 1, okay. Or whatever. I think it's even cool. I can see it's exactly where you plotted. Okay, no problem. Since you couldn't draw a proper straight line because of the device you used, I will just say, oh, since I can draw it now, let me just clean it. Okay, I can join when x is 1, y is 1. When x is 1, y is 1. There's somewhere here. And I join the straight line. What can I use? Let me use red. All right. That's been done. Did I say we should solve the equation?
No.
di, we have drawn that. Eventually they will ask us to solve the equation. I'm telling you the truth, because they wouldn't give you that thing just for the fun of it. Okay, now this other one, read it out.
The equation x cubed over 2 minus 3x minus 1 equals 3x minus 2 can be written from x cubed plus ax equals 0.
Okay, what are the, find the values of a and b. What did you say you did?
Yeah, so what I did here was that I made x cubed over 2 the subject of the formula. So I moved minus 3x and minus 1 to the other side.
Is that how you were able to find a and b?
Yes, so after that I cross multiplied and then I found the answer like that.
Okay, let me do what you said you did, because you know, based on what we talked about earlier, if you want to remove, because this equation, okay, I think I need to zoom in so it can come out better. Basically what they're asking you to do here is to re-express this equation so that it will now be in this form. And this is raised to power 3. This is also raised to power 3. So what will you do based on what I told you earlier, and I've told you some time ago? When you have a no, normally if you didn't want to use that method, what would you have done so that the fraction will disappear? Because it's basically asking you to re-express this equation in fraction to a straight line equation. What do you do to remove the fraction?
I multiply everything.
You multiply all. Yes, you multiply all through by the LCM, which is 2, or the product of the denominators. Assuming this was 3, the other one was 4, you multiply all the denominators. Your answer, you're going to be multiply each term by that answer, assuming you got 30 by multiplying all the denominators. Each term by you multiply each term by 30, each term by 30, each term by 30, all through, and the fraction will disappear. Okay, so the LCM is 2. We could have multiplied all through by 2, but I will still use the method you used. Everything times 2, everything times 2, everything times 2. Each one times 2, each one times 2, each one times 2, all the terms. Like here we have 1, 2, 3, 4, 5 terms. Each of them must be multiplied by 2. Okay, but let me use that method you used. You said you moved everything to maybe the other side. You made x over 3 the side of the formula. That's fine. Let's do it.
But I didn't move. Yeah, yes, I meant x is power 3.
So the formula, this will be 3x plus 3x minus 2 plus 1. I'm just collecting like terms. 3x here, then minus 3x crosses over, becomes plus 3x. Then minus 2 here, I've written it, minus 1 crosses over, becomes plus 1. In fact, this would have been simply become x raised to the power 3, because it's better to simplify this right hand side before you continue. It makes the work easier. X raised to the power 3 over 2 is equal to 6x minus 1, isn't it? And then you cross multiply, and you got x cubed x cubed is equal to 12x minus 2, and you carried everything to the other side, becomes x cubed minus 12x plus 2 equals 0. Alright, so a is what? Minus 12. B is 2. That's correct. Just comparing. Okay, that's correct. A is minus 12. B is 2. Makes sense. This other one, I told you they will definitely ask you to solve this. It says use your graph to find the positive answers. X over 3, x raised to the power 3 over 2 minus 3x minus 1 is equal to all that for minus 3 less than or equal to x less than or equal to 3.5. So they've given you the domain. Okay, what did you do?
What I did here was this. My answer was x cubed minus 12x. So I substituted within that, did it that, and then I picked out those that were possible.
Why are you making things difficult for yourself? You can see they said use your graph. Use your graph. The reason for asking you to plot another graph is so that you can find where the two intersect. You know, you plotted a second graph. after the first graph. You know what I mean? After the first graph, you still plotted another graph. In fact, this first graph is this equation, the curve, and the second one is the straight line in red. So when you equate both of them, you know that it will just be where the two graphs intersect. Do you now remember? Do you now remember? So they are basically asking you to locate where the two graphs intersect. That's all. Where this first graph intersect with the second graph. That's equating one with the other. When two equations are equated to each other, like if you have y equal to x cubed plus 3x minus 1, for instance, then another one y equal to 2x plus 3. If this is equal to this, it simply means plot the first graph, plot the second graph, wherever they cut will be the answer. That's all. So where did they intersect? Where did they intersect?
Intersected.
You can circle them. Use a yellow line and circle them.
Here and here. -2 and
Please circle them. Circle. Use a yellow line and actually circle them. I want to be sure you. Yes. Okay. There and there. You mean here and here? Okay. Okay. You can undo. Your circling is too much. You can undo now. I can see. You know the point. All right. Here and here. So the values are what you need. Why they say you should use only the positive values, because by the time you continue to stretch this one, you will also get a negative part. But it's only the positive ones that are important in this question. Do you know that if we continue this graph, eventually it will cut another point on the curve. It will still cut another point on the curve. But they don't want us to talk about the because that point will be a negative value of x. You know, but we are only interested in the positive part. So here and here. So what's this value?
that value is -2.
Are you sure? The value on x. On x. Remember the see the question. X. The values of x. In fact, when you are looking for the solution, it should be the x values. The x values. The x values you are picking. The x values. So what are the x values of those point of intersection? The x values.
So I substitute.
No substitution. X values of that point of intersection. That's all I've been saying.
So 0.3 and 3.
0.3 and 3.
0.3.
Yes.
Around 0.3.
Around 0.3. Or we can even say 0.2. X equal to 0.2 and x equal to 3. Please, you need to be careful how you jump into a question and make it more complicated for yourself. You know, they said use your graph. So obviously, the simple thing is use your graph. So x values at the point of intersection 0.3, that's x equal to 0.3 and x equal to 3. And they've even limited your scope of answer within this region. This is called a domain, isn't it?
Yes.
Okay. The domain is from -3 less than or equal to x less than or equal to 3.5. You know, for what you're going to do. Now, if they wanted you to find the y values, you can now find their y values. Trace it to y and also trace it to y. here it would have been around y equal to 7 point something, or approximately 8, and y equal to minus 1 point something. In fact, that's another way to also solve equations. In fact, this is what we call the graphical method. Instead of using the analytical method where you solve, you just plot a graph and find the point of intersection of the graph. I've mentioned this to you before. If you have two equations and you to solve the two equations simultaneously, just draw their graphs. Where the two graphs intersect will be the solution. Do you remember now?
Yes.
Okay. Just draw their graph, the graph of the first one, the graph of the second one. Wherever they intersect will be the solution. That's the solution of the simultaneous equation. You can use that to even solve simultaneous equation. Okay, I think that's cool. Is that good?
Yes. It is.
Okay, basically that's what we did in the other questions we solved. Solved earlier on the previous page. Like this one on page 7, where we drew different kind of things because of the question we asked. And even this one on page 8, all right. I believe you should be able to ask these kind of questions. All right. Please don't forget to like, subscribe, and comment. Thank you so much.
Welcome to Like Learning School, your premier online education platform. At Like Learning School, we are dedicated to helping students and learners unlock their full potential, providing them with the foundation, support, and guidance they need for academic excellence. Our platform caters to two main target audiences. Firstly, we work with school children of all ages, offering academic follow-up and accountability partnerships. Our seasoned tutors provide personalized attention to ensure students stay on track and reach their goals. Secondly, we support students and learners who are preparing for internal, external, entrance, or professional examinations. We offer comprehensive and well-structured support to help them achieve outstanding performance in their exams. Our robust virtual courses are designed to keep students engaged and motivated. With interactive videos showcasing our teaching sessions, students actively participate in the learning process, making education enjoyable and effective. But that's not all. We believe in personalized education. Our students have access to personalized tutorial sessions, whether online, physical, or hybrid, tailored to their unique learning needs. Join us at Like Learning School and experience a transformative education journey. Visit our website at www.likelearningschool.com or contact us at +234 808 509 5144 to learn more and get started today.